Hey. That's what I do, man. Oh, nice. I just want to refresh people's memory now. What was about. Oh, thank you. I'm sorry?
We were overflowing in secret.
Because really, why wouldn't you?
There was a working group meeting once where all the run tables were taken with only one chair, so I just set up with the chair. It's the only place I could find a table. But you have three.
Yeah. What time is it?
What time is it?
Almost that time, isn't it?
Yeah, you're actually 2 over.
I'll give people a few more minutes to get settled in. Looks like we're going to have a packed house. Oh, we can't start until our Jabber Scribe shows up. All right, folks, let's get this started. As always, we've got a nice packed agenda. Maybe
Yeah,
not so
we know
packed
everybody's
this time.
very excited about getting together.
It is it's a full house. Welcome to DNS Operations.
We are not HomeNet.
I am Tim. That is Suzanne. We are not HomeNet. Yes, we are not HomeNet. Dan's our Java scribe. He's right next to the mic. Mr. Paul Hoffman back there is our minute taker. Thank you to both of them. So you know the note well. You see it a lot of times. You know, just pay attention. Please fill in the blue sheets. I know I started passing them around. So you'll see them come by at some point. Also, folks need to stand in the pink box if you're talking for the remote people. We've got some updates on some old work, some current stuff, new stuff, and yes, there's some special names discussion, but it's going to be much shorter than it has been in the past. So, some quick document updates. Since our last meeting, we've gotten a few things out. Chain query, EDNS chain query came out, is now 79. DNS cookies is now finally out. So I want to thank Donald and Mark for making that all happen. And we finally got DNS client subnet out, even though it already showed up with errata. So that made the long road, which was a very slow, painful process. And of course, immediately it had a few, mostly minor stuff. We called IST the wrong name. And there was, I think in some of the V6 examples that they put in at the last minute to satisfy the V6 requirements, there's a mistake in the subnet mask. But hey, that's not bad for a couple months. Currently, we got sitting in ISG evaluation, roadblock avoidance, and I believe Wes we managed to sort of deal with all the updates with the ISG comments, and I think we can move that forward. Maintain DS. We're doing some formalized edits in there to 2308 and 1034, and actually a new version of that came out. Nope, I'm sorry, I got those backwards. Maintain DS. Actually, I think we're sitting okay in it's just in IESG state right now, and it's NX domain cut. I just had Stefan push out a new version, mostly to formalize the language around the 2308 and 1034 updates. It's basically the same draft with just one section that has just the formal language for the RFC editors. And that actually came out probably a couple hours ago. And I've got still a couple that we're sort of sitting on, and we're being very recalcitrant and getting everything out the door. So what's next in our pipeline? I kind of put this together. Paul and I kind of sat down and put this together. This is what we're looking at in sort of the working group last call list. This stuff will start coming out probably after this, after this week. Resolver priming is mostly done. All the updates are there. And I think it's one of those that we just have to get done. The refuse any draft that Joe and Oliver and those guys did, I went through it really deep over the weekend, and it looks really in good shape. And then the other three are the key tag, which they've made a recent update to it. And I think the working group needs to sort of discuss about the two different options. They've got now two different options, the EDNS option and the QNAME option, and they've got both in there. And I can see pluses and minuses for both of that. And then the last two ones is the 2317 update, and the last one's the wacky Dave Crocker document on attribute leaf, which is, I think at this point, it's a very necessary thing to do. So I'm just trying to hear back from Dave on when we want to start moving on that one. So. It's a necessary wacky document. It's a necessary wacky document. Yeah, it tries to describe all those sort of underscore labeling things that go on, and it puts together a registry that actually basically documents all those pretty carefully, and he does a very good job of it. And something like 10 years ago, I would have said like no way, right? But now there's so much stuff going on with that it's kind of like it needs, it's probably the right thing to do.
This is Murray. If you need help with that one, let me know.
Yes.
Dave's
Murray. Yes. Yeah. I was going to go back to. I think the apps people need to sort of go back, and I need to talk to them about that. Yep. We had that discussion. Okay. So, and we've got currently the DNS wire format draft in call for adoption that people seem, pretty good about. And I think it's sort of come together, and we can start working on it as a working group document. So, and then that was kind of it on that. And then Matt Larson's back there. He's going to speak about the KSK rollover stuff. So go, Matt.
Hi, Matt Larson from ICANN. So Dwayne Wessels from VeriSign and I are going to talk tomorrow in this room during the lunchtime session, whenever that is. What, 12:30? I should know.
Yeah.
But this room, we're going to talk about some details about some upcoming changes, the ZSK, the root zone ZSK size increase, and the root zone KSK rollover that's coming. So if you want to come and hear about DNSSEC in the root zone, but not get any food, you can come.
They will not feed you. They will not feed you.
You
remember.
can come here tomorrow at 12:30. Thanks.
So I think that was basically it. And then, of course, we're going to have a little update on the NSEC aggressive use draft. There's been some good updates on that after it's been adopted. And Sarah's going to talk about the DNS over TCP TLS. And we've got some new working group business that not yet for adoption, but we're sort of considering it. There's some stuff in there and I've added a few things to the bottom, mostly Dan's draft that he put in IEPG about DNSSEC crypto algorithms. I just included that in the materials because I think it's really interesting stuff. And I looked at his presentation, and I really liked it. So, so there we go. So Paul, if you've got a minute to discuss. Okay. You can do that.
I'll just do this because I've been too busy. Take a minute. Yeah. So for those of you who are newish, that didn't help. Does this help? Is it on? Okay, good. For those of you who are newish, Dnsop working group last year finished a terminology document where the purpose of the document is to pull out all of the relevant definitions of DNS terms that are used in RFCs. We thought that would be easy. It turned out not to be as easy because we discovered that there was some contention on, even if RFC foo said bar, no one's doing it or half the people are doing it. So when we finished that document, we did finish it, as we were doing it, we purposely punted on a bunch of things and said, we don't have consensus now, we want to go ahead. So we'll do a BIS. So we have started doing the BIS, and we just turned in draft 01 last week. We said we were going to start doing the BIS quickly, and we missed the quickly part, but we did start going. So apologies for that. In the 01, we've already started adding new terms. So that wasn't really our expectation when we started the BIS. We thought we were just going to fix things from before. Oh, I'm not even in the pink box. Now I'm in the pink box.
I didn't want to call
I can't even follow my own instructions. So, but we discovered that there were a bunch of terms that we hadn't seen in the first one, which are from RFC. So these should be pretty non-controversial unless people disagree. So we already threw a couple in. Closest and closer is a great idea that no one understands. So it's good to actually have the term in there. You know, if you say to somebody outside this room some DNS terms, they'll understand them. If you say closest and closer, people are going to go like, what are you doing? So we put in some of those. The secure entry point, the SEP, we have a definition in 7719. A month ago, I discovered that, and we used RFC 4033 or 4034, I forget, as the definition for that. I discovered that that was actually based on an earlier RFC that had a different definition. So all of us, all of you, I guess, or DNSX people, adopted a new definition for SEP when you did 4033, 4033, 4034, but some people remember the old one. So we had to put in something going, we're not talking about that anymore, but we needed to say that. And in the beginning of the 00, we had some stuff about, oh, we're going to start doing this. We took that out because now we're doing it. So where we want to go with this is that I, or the authors, but some of you might even help us, will review all of the list traffic from that went into 7719, looking for places where we punted. And we will keep a list, a punt list, and we will unpunt. So that one will be a little bit painful because it wasn't like we punted because we were in a rush. We really punted because there was real disagreement among friends about stuff. So that will be difficult, but we will go through that. The next thing we're going to be doing, and we agreed to do this before, is RFC 7719 doesn't update anything. Even though some of the things say, RFC foo said this, but that's wrong, that should be an update of RFC foo. So we're going to start marking those as well. We aren't going to update an RFC that we quoted exactly and agreed with. That's silly because that's called duplication, not updating. But we will, when we're done with this new document, there will probably be at least 10 things in the updates list. So even if we only update something a little bit, it's important to say that so that somebody who's looking at that in the RFC collection will see it's been updated by such and such, even if it's one thing, because these are definitions. So we want those to be, you know, findable in the future. And so our plan is to do updates to the draft about once a month, even if it's small. We just want to keep things going because in this working group, If you don't keep people's attention, all of a sudden it's a year later, which is how we sort of blew getting the 01 out. So we're going to do this. It's not going to be on exactly on the first of the month, but we're going to try to do that. So some of those will be big, some of them will be small, but we want to keep people's attention because it's not like that this is the most important protocol stuff, but having the definitions right, everyone agreed when we started this, is a fairly important thing. So we would love to have more reviewers. And I want to emphasize this, if you're in this room for the first or second time, or if you're in this working group for the first or second time, you are a prime reviewer for this document because you have the fewest preconceived notions of what a particular term means. So if in reviewing this document you are surprised by any definition, that's very valuable information. Also, you're the kind of person who might be surprised because you found a different definition in some other RFC that we all missed. Like I said before, the SEP definition. We all went through this and no one pointed out that an earlier RFC not only had a definition, but it was different. We want to find more of those. That's really, really valuable stuff. So we're going to look for more reviewers. All of the old folks have been here forever. Yes, we still need your reviews as well. But we want as much fresh review as we can. So I believe that's it.
Okay.
Yeah.
One question I had was, you now have BCP as for the BIS?
Yes.
Okay, not standards track, even though you're gonna be updating other.
BCP is standards track.
Okay, that's
They-
sorry.
Technically, they are sort of in the same realm.
Yeah,
Yeah.
because you'll be updating documents. Okay.
Okay.
Benno Overheijn and Nelnet left. Just, I didn't follow the full discussion before in previous IETF of Dnsop working group. My question actually, so what's the goal of the document? Is an inventorization of all the terms being used, also getting some recommendations?
No.
For example,
No.
definitely not.
No,
Okay.
absolutely not.
So-
So there
so
are
the
plenty
thing
of
is-
terms for
okay.
which there are probably no implementations yet,
Yeah.
or important implementations. We still want to get the definitions right in case someone comes
Yeah.
along and goes, I'm going to do such and such. We want to make sure they're starting with
Okay.
the right term.
So it's really neutral. And for example, the full resolver, well, this term is not properly defined in any RFC. You don't say, don't use this, or there's no.
That's one of the very contentious ones, was
Yeah.
resolver, full resolver,
Yeah.
and
Yeah.
stuff like that. And do we define resolver or do we define resolution?
Yeah.
So that was very contentious before, and those are going to be the hard questions
Yeah.
that we're going to try to.
Yeah, so, okay, so probably this won't be touched in this document, but I think it's at some time good to have some canonical name, a set of canonical names people, are
We might go towards that.
suggested to use.
Yep, we might go towards that, and I think that would be appropriate here as new stuff. That's not an
Doesn't it?
aim,
Okay.
but we might. Especially if there are two things that sound alike, that everyone really is talking about the first one, but the second one sounds enough alike, where we might try to separate that out better.
Thank you.
Yeah, that sounds like a wonderful thing to pursue on the list. Because
Yes. Yeah, topic
it's
by
kind of
topic.
generally, we kind of asked him to stand up here and say, please read the draft. But Aaron, go ahead.
Aaron Falk, I have a serious suggestion. If you can't come to agreement on a term, perhaps a disincentive or an incentive for coming to agreement is that you shouldn't use the term in any documents because there may not be agreement on.
Right, but remember, we're only doing terms that were from earlier documents. We can't take them out of the earlier
I
documents.
recognize that, but this group has a rather long list of documents that it's working on.
Right, so that might be something that if you're using a term that we can't come to agreement on, maybe you have a problem in your own document. That hasn't been the case so far. The disagreements were really on things, on the old stuff, resolution, resolver, some of the real basics we have, or quite frankly, secure entry point. That's something that everyone here who is, familiar with DNSSEC thought they knew what it was. And it turns out we had changed our mind and we ignored it, so.
And the other thing is, as someone who reviews documents in other groups, they talk a lot about DNS and they use terminology that is very wildly different than what we actually believe is the right term. So I think it's good to be able to point people to say, hey, this is really what, if you want to talk about DNS stuff, here's some of the words you need to use, kind of thing.
But just a quick history for the people who don't remember when we started 7719. One of the reasons why we did this not only was to collect, but since people here know about internationalized domain names, in the world of internationalization, terms were wild, and where they weren't even defined in IETF documents. We were going out to Unicode and ISO and stuff. It was a total mess. And once we did, I happen to be a co-author on the first internationalization terminology document. Once we did that, it all got much better within a year. So, you know, if we can do that here, that would be great. Thanks.
Okay, thank you. Oh yeah, Warren, I know you're here. There's been some great updates to this draft. So if anybody hasn't read the latest version, I urge you all to, because I think they've really, Warren and Mr. Fujiwara have really done some great stuff. So.
Wow, Paul's way too tall. Everybody's way too tall from my standpoint. So this is going to be a short update on the aggressive NSEC document, also usually known as the Fujiwara document. Next. Oh, I've got the thingy.
Yeah.
Wow, cool. So sometimes simply knowing that you don't know anything can be really useful. Thank you.
That's what a transport guy does.
There we go. So a quick refresher for those who've forgotten what that is, and an introduction from those who haven't read the draft, which I'm assuming is a fair number of people. Here is a query for .belkin. This example is at the root, but this technique works anywhere in the tree. You get back an NX domain telling you that .belkin doesn't exist, but you also get back this NSEC record, which tells you that there is nothing between .beer and .bentley. You also get a bunch of crypto goop, which proves that. And what this document largely says is, because you've already been told that there's nothing between .beer and .bentley, you shouldn't do any lookups for other strings that fall between that. So things like .believe or .beggar, similar things to that. You've already been told that this does not exist. Recursive name servers should simply put this in their cache and believe it. So we actually have a real world example of where this would be helpful, and ended up being helpful. On, what date was that? May 12th. Kaveh and Colin from Kroot poked me and said, for some reason, Google is suddenly sending us a bunch more queries to Kroot. They're all of this form random string dotted quad, although for some reason the dotted quad has lots of octets that are larger than 255, and what the hell are you doing, and please stop. They, of course, yeah, it was a Friday afternoon. Things always go boom on a Friday afternoon. But in the space of around 4 hours, the number of queries to at least some of the Kroot nodes had increased 10x. And this wasn't actually causing an issue, but if it continued like that, it would probably be bad. So we started having a look around. You know, has Google Public DNS got some new bug? If so, who touched it and why? But we had a look at our incoming query stream, and sure enough, there were a lot of people looking up names of that form. So it looked like possibly a DOS attack, although what seemed a little weird is that looks much more like organic growth than a DOS attack. DOS attacks usually sort of a straight up line and then it goes across, and this was continuing to grow, and oh no, why? After some more looking, it turned out it wasn't just Google Public DNS. Just because of our scale, we kind of show up towards the top when people have a quick look. So at least then we knew it wasn't just us, wasn't just a bug. But still, what is this, and can we make it go away? After some more looking, we found there was this new worm which infects ubiquity access points. It was actually an old vulnerability that a lot of people hadn't patched or upgraded. And so, you know, at least we knew what was causing it. It was spreading very quickly. Now at least we know what it is. Is there anything we can do about it? So this, is a query, or sorry, a graph of queries from Google Public DNS to b.rootservers.net. And I checked with B, they're okay with me mentioning this. For the folk who are at the back of the room, the x-axis is May 7th through June 25th. And the y-axis is 0 QPS through 3000 QPS. So Google Public DNS already had this aggressive NSEC stuff in. We'd mainly been using it to mitigate DOS attacks, and we turned it on in some places, but not everywhere. Before May 12th, we were sending about 450 QPS or so to Beirut. Then you see, oh, I have a laser. Then you see, squirrel. So when the worm happened, it spiked up to around 2,500 QPS or so. We found the top 4 sites that were sending these queries to root servers, and we turned on aggressive NSEC at 100% there. And, that dropped it down a bunch. But as I say, it was a Friday afternoon. We prefer not to make production changes on a Friday afternoon. So we let it bake for the weekend. We turned it on half of the machines in all the other locations just after the weekend. And that's the second big dip. We let it bake for 2.5 weeks or so. And then finally we turned it on at 100% everywhere. And now original sort of 450 QPS, now it's down to around 50 or 25 or so QPS, which is the line over there. And this is one root server. It's kind of representative. Some have more, some have less. So the draft itself, this is sort of the summary of the changes. Here they are in more detail. The document was adopted by Dnsop. We integrated all of the adoption comments. Jinmei suggested that we make it less, or change the focus to be less from mitigating subdomain attacks to just general performance improvements, general reducing additional queries. Bunch more good comments that we integrated things from. I got added a co-author. Oh yeah, we simplified the NSEC3 pseudocode and actually rewrote a lot of the text and added a bunch of examples to make it easier to understand. Couple of quick notes. One of the things that this technique does is it potentially occludes newly added information. So if you query for foo.example.com and you get back an NSEC that says that nothing exists between a.example.com and q.example.com, that will be true for the TTL of the NSEC record. If you add a new name in that range during the TTL time, a lot of people aren't going to see it. We kind of think that that's what the NSEC TTL means, just making that clear. Some implementers have said that NSEC3 is much harder to do than NSEC. What we say in the draft is if you only do NSEC, you're still compliant with the draft. You should try and do both, but if you don't, whatever. We also suggest that there should be knobs, or that implementations provide knobs for enabling and disabling this on a per domain basis. So if you enable this and you find some set of domains which have weird issues, you can turn it off, or the other way around. And we think that we have integrated all of the comments, other than Jinmei suggests further removing references to subdomain attacks. There are a couple of tiny grammar and typo fixes, which I meant to make, but didn't get in before the draft cutoff. And over here is where we're working on the document or collaborating on it. We gratefully accept pull requests or any other comments that people would like to make. We'd very much like people to review it. But so far, we think we're basically ready for working group last call.
Aaron Falk, a quick question. Can you go back to your plot for your example? I noticed that after you turned it on 100%, that the traffic level was lower than before the attack started. And I'm wondering if you're feeling confident that there was no collateral damage.
Yep. So yes, before it was 450 or so QPS, and a lot of that was just junk queries like .belkin and similar. Since we've turned it on over there, we believe that everything that should be being resolved is being resolved. There's no way to tell that definitively. The reason we had it on at 50% is we ran it and did sort of an A/B test to see if there were any legitimate answers that were being dropped. Obviously, if somebody were to have added a TLD during the time that there was an NSEC record, it would take, however long the root NSEC TTL is to show up. But yep, we believe that there is no collateral damage currently.
I'm John Levine. For this particular application, you could have done the same thing by mirroring the root, which we've
Yes,
also
we could have.
discussed
Yep.
in some detail. My first question is, do we have evidence of other places where where we would actually get this kind of big win. I'm just thinking the larger the domain, the more likely that they are to be doing, to be signing on the fly. The more, if they sign on the fly, the more likely they are not to be returning interesting negative answers. So I'm wondering, I mean, I think this is a perfectly reasonable thing to do. My concern is just it'll turn out to be a fabulous thing that in fact, in practice, doesn't give you much more than mirroring the root would.
Yeah, so somewhere I do have some set of statistics, but I don't think they're anything I can usefully publish. The root does seem to be the place where you get the biggest one. But for places where you might be getting, potentially sometimes under DOS attacks, this will be useful too. If somebody's doing a dictionary attack, this helps cut down on queries hitting your authoritative server.
I proposed this some years ago and people told me I was stupid. So I'm glad that we all kind of evened up here. But,
Rising tide.
Yeah.
Feeling vindicated.
Yeah, but the context, the context in which I improved it, I suggested it was V6, reverse DNS, and blacklists, because they tend to have sparse things with a lot of stuff between them, and also particularly with blacklists, people are worried about the stuff getting copied. Yeah, my only having actually read this draft, my only pragmatic concern is there seems to be a certain amount of what strikes me as gratuitous advice, like saying, oh, you shouldn't do stuff more, you shouldn't cache NSEC for more than 3 hours, which is what you copied from something that Mark said in 1998. And it may still be true, but I think it might be worth, or it may not, but
I'm not sure if that still exists in the most recent version, but it's entirely possible it does.
It's the one you cite.
Does
It
it?
does.
Okay.
Yep.
Oops. Okay. It needs a bit more scrubbing then. I couldn't remember if we'd taken that bit out.
Sit down. My personal preference is simply to say, this may be the issue, but unless you have a concrete basis for your advice, just say, think about it, rather than saying, this is the answer.
And yeah, anybody else who's willing to read it and provide comments, please do. We really would like them.
Hi, Dwayne Wessels. So the draft applies to more than just the root zone.
Yes.
Right. Did you turn it on for more than just the root zone? Can you say?
Yeah, we turned it on everywhere.
Okay.
I'm not sure if I can say, but I just did. So hey. Yeah. So originally, I was working on the cheese shop draft, which largely said just do this for the root. The aggressive NSEC document says do it everywhere. Cheese shop I thought was good because it was easier to get agreement on. If people are happy doing aggressive NSEC and it moves along quickly, it seems like that removes a lot of the need for cheese shop.
I agree.
Good.
Great.
And note the next process step here is going to be working group last call. So,
Get some more. Yep.
oh, you have pending edits?
I have something to send you.
Okay.
Great.
Then-
So I now have some, and I had to do Jinmay's please remove references to subdomain attacks.
Okay, then we'll plan on doing a working group last call for the next revision.
So I think Sarah? Yep. This is kind of a little deprive intermission because we didn't have enough to actually have a real deprive slot. So we wanted to talk about implementation stuff. So there you go. Oh, and-
Yeah, so what I just wanted to do was give a bit of a snapshot of the implementation of DNS over TCP and TLS features. So RFC 71066 came out in March. So I wanted to just run through on some of the main softwares where they are in terms of that implementation. So this is looking just at recursive servers, recursive resolvers. So the top set there is the TCP features. Excuse me. And what's particularly nice to see is that Not Resolver has had the TCP features in there from their first version, which is really good. And I want to call out Andre, who's here, there he is, hacking away like mad over the weekend, working hard on the TLS feature in Not, which is getting to be in pretty good shape now, I understand. So it's all good. And there's more work going on in Unbound, which should happen in the next couple of months to fill in the pictures there as well. Something else that's come up in a lot of discussion is that on the server side, you could also play some other tricks rather than having to have native implementations, particularly if you want TLS support. So a lot of people have said it would be lovely if something like DNS dist actually did strong TCP connection management and TLS. It's not there yet. Other ideas have been around using proxies like Nginx. And Francis has written a really nice article on about how you could use bind combined with S-tunnel to act as a TLS server. It still requires that the server behind it has good TCP support if you want to use this proxy model, because it needs to be able to do concurrent processing of queries and its own TCP connection management as well. So it's not something you can drop in front of any implementation. It needs a bit of thought. We've noticed a little nuance with the handling of keep alive between a client that's talking on TLS and a server that's running TCP. So we need to come up with a solution there. And of course, if you do that, you don't have any DNS specific controls right at your sort of access point. But it is one way to move forward with providing a service. On the stable implementation side, I've shown this quite a lot before, and I talk a lot about GetDNS and how wonderful it is and how green it's looking. Which is all good. What I did want to point out is that I've added a couple of new columns here. One is I was talking to Meet Gideon about his Go DNS library, and he's got TLS in there now, which is nice. It doesn't have the authentication yet, but it does have most of the TCP features too. And again, KDIG got a lot of attention at Hackathon this weekend, and thank you. So that was the authentication is also happening there. So that's great too. So just in terms of if you actually want to try these things out, NLNet Labs have some test servers, and now OARC also has a couple of test servers that are offering TLS. The details are there. And GetDNS, we're working on a daemon mode, so you can set it up on your end machine as a local stub that will forward over TLS. So that's a work in progress. So any feedback on that's much appreciated. And if you were at RIPE in Copenhagen, we had a discussion in the working group there about RIPE offering these services. So this is happening. We've been talking to them this week again in terms of coordinating an effort to provide these services, and possibly RIPE also running one themselves. And just finally, just to mention some things that are still ongoing. We're working on a patch at the moment to DNS Perf that's going to add TCP to it, and it's going to add TCP as of RFC 7766. So you'll be able to use that to pipeline queries to actually measure the performance of the name servers. And we're getting some really interesting numbers out of doing that. So hopefully we'll be able to publish that shortly too, because most of the historic capacity measurements were done with one-shot TCP. And finally, we still have the profiles draft, which goes into the details of how the client can authenticate the DNS server. It's had two small updates since the last IETF, one on reworking how we describe opportunistic and strict, hopefully making that much more obvious, and a small one about Dane. So please review that. We'd like lots more comments and feedback on it. And that's the end of me. Thank you very much. If there's any questions.
Andre Suri, CZNIC. Sarah, the test GetDNS API servers you have, could you add support for padding?
Sorry, the server or the client? The
server, because, well, me and Alex wrote a EDNS padding just before this session.
I see, yeah.
We have no server sites to test.
So in there, that should, the padding for...
It should be in Unbound or, yeah.
Yeah. Okay, will do. Yep, thank you.
Thanks. Yep. Yeah, those deprived chairs are kind of slackers, so we have to get on them. So awesome. So here's some new work that's coming up, and this is probably the first one that's sort of definitely a candidate for adoption. And there's some work in DNSSD that's sort of gating on this, but it doesn't mean we have to adopt it, but it just means that there's definitely some good stuff going on here. So Ray. I think I have the most recent ones.
Yeah, I think so. So firstly, apologies, I'm a bit frazzled. If you've been in a HomeNet before this meeting, you'll probably understand why. How's that? Okay. Okay, so a bit of history on this, as Tim just alluded to. We've got the problem with the EDNS is that it's got per message semantics most of the time. Let's say if you can read the IETF in the middle, except when it isn't, because there's an interesting discussion a couple of weeks ago about what you're supposed to do with the response UDP buffer size in a packet. Let's not go there just now. In EDNS TCP Keep Alive that Sarah and I and a few others worked on, it was published fairly recently. We kind of fudged around that. Keep Alive is actually relating to the state of a TCP connection. There are all sorts of rules about when you can and cannot reply with an EDNS option on a packet. We fudged around, it wasn't ideal. And we had in mind actually fairly soon after writing that actually really what we needed was a better signaling mechanism for stuff that is supposed to be persistent when it's relating to a session. We also then, having had Stuart Cheshire and Tom Pisteri pointed in the direction of RFC 7828, when that was brought to their attention, realised that there's quite a lot of overlap in their own draft on session management or connection management. So one of the first questions we got asked actually by Ted Lemon when we published this a couple of weeks ago is what do we actually mean by a session in this context? And we had an interesting meeting this morning with our co-authors, and this is what we've come up with, is a session is something that has a long-lived connection that is bidirectional such that either party can actually initiate messages over this, and that the messages are delivered in the order in which they were sent. So this clearly applies to TCP and also applies to DNS over TLS, but would appear to exclude anything that uses UDP, and that includes DNS over DTLS. Sorry, that's a mistake on the slide. It should say DTLS on the last line. It also would appear to preclude, for example, DNS with cookies, because anything using UDP, there is simply no guaranteed returned path if the server wants to unilaterally send a new packet back to the client that wasn't in response to something the client sent. So the proposed design currently, and this may be contentious, is that we're going to find a new opcode which is independent of any query or other message that's being sent along the wire. Currently, looking at doing that with a minimal header, not a completely empty header, which would just be the 2 bytes of ID and 2 bytes of flags. But for now, at least, we've got this option of having the extra 4 section counts all being 0. The rationale for that was that existing parsers should essentially treat that as stuff as trailing garbage, and they shouldn't actually reject anything. And mostly here looking at not simply responders, because clearly responders would need to be updated to know anything about this anyway, but anything that's doing packet captures of DNS packets like DSC or any code like that should at least not sort of fall over on a heap. Again, this session this morning, actually, we've maybe revised that view a bit, that actually client code and parsing code already has to be resilient to garbage appearing in packets. If you've got code that falls over because it sees that the 5th and 6th bytes starting from 0, where the question count are, say, there are 65,000 questions, and that causes your code to fall over, then your code's already wrong. So coming around to the idea that actually we would just have the 4-byte header and then put in a TLV. There's also some question about whether we actually need to encode multiple TLVs within a message. If you've read the draft, you'll currently see that there's a 16-bit word which contains both the tag of the TLV that's been exchanged and a 4-byte status code which is per TLV. There's actually potentially quite massive simplification if we say that there's only going to be 1 tag per signaling opcode message, because we can then actually just use the R code to represent what happened to that message when it was sent. Similarly, if we do go for that one, We argue that every TLV must be explicitly acknowledged. I think it causes problems for TCP and delayed ACKs and Nagel's algorithm. If you send something back, the client's got to send back an ACK anyway. So you may as well actually have something in there, and we should explicitly acknowledge whether the far end server has actioned that option. Actually already mentioned that in whatever size, either party can initiate this. So if a server needs to unilaterally tell the client that something has changed relating to state, there's got to be the return path there. And that's also expected to be of utility for the DNSSD push, where having subscribed to a 3-tuple of QNAME, QType, QClass, that you want to be notified of updates to that, there's an expectation that those are going to come back down in the same session, but that's going to be initiated by the server. So the requirements for bidirectional signaling on here are the same as the requirement for DNSSD push. And that's it. It's in an outline. Questions?
Have you thought about how this interacts with the HTTP wire format draft and where the interaction should be documented?
No.
And sorry, can you state your name?
I'm Ben Schwartz from Jigsaw.
Okay, thank you.
No, I don't think we have considered interaction with HTTP yet. No, we haven't.
Not HTTPS, but the HTTP wire format draft. So, okay, offhand, I think it's going to be non-trivial and maybe surprising.
So, unless the HTTP stuff is done using a long-lived HTTP connection, I don't believe there would be any interaction, because if you're making a new TCP connection, sending a query over HTTP and then closing the connection down again, then it simply isn't relevant anyway. And also HTTP, in most circumstances, not sure about maybe HTTP2 or other stuff, you're not typically having stuff sending back unilaterally anyway.
Right, HTTP2 supports push notifications and also is not order preserving.
Yeah, well, order preserving is important here, because if you've got one option being sent that sets a particular stateful condition, and then the next packet comes along and unsets it, it's clearly required that those actually be processed in the correct order.
I just would like for the interaction to be documented somewhere.
Respectfully, I think maybe we should see what happens with DNS over HTTP before we worry about that too much in this draft.
Hi, Aaron Falk again. I did not follow the entire discussion, but I wanted to point out that there's a BOF on Thursday morning, the Plus BOF, that is talking about a way for applications over DTLS and UDP to expose some session semantics to devices on the path, things like NATs and firewalls that need to keep state open. And if you're a battery operated device, then not having to send keep alives is useful. I don't see, as far as I can tell, I don't think this is competing, but possibly complementary. It looks like the direction that you're going in may be a potential user of something like Plus.
Yeah. Do you happen to know off the top of your head if that would likely keep the order preservation requirements?
I don't think that's required. I think that's a matter for the application. The thing that's sitting on top of Plus to do if it requires it.
Stuart Church at Apple. I can speak to that point and also ask my question. This document defines a session as something that has the properties of being in order, being relatively long-lived, and supporting bidirectional communication. If Plus or Quick or anything else defines a session layer that has those properties, then it would be a suitable substrate for this. And that this is sort of this typically today would be run over TCP or over TLS over TCP. If something like Quick were to provide suitable semantics, it could be run over Quick. And this document is merely defining the requirements of the lower layer. Because we didn't want to say this is only for TCP. We wanted to make it a little bit broader that other things with similar properties will also work. And the question I have is not for you, Ray, it's for the room. So as a co-author on this, one of the debates we had internally was to go the minimal route, which is just have a 4-byte header followed by a payload, which is determined by the opcode and existing TCP dump code would probably get confused by that. The other approach is to follow the EDNS 0 opt approach of having something that masquerades as a resource record so that it takes more bytes, but it's less surprising to debugging tools. I'm leaning towards the minimal 4-byte header, but I'd like to get the sense of the room because I don't feel strongly either way. We want to write a document and get it published and get it implemented. So if there's strong feeling in the room, let us know and we'll probably go with the consensus.
Any opinions either way?
If you have to stop and think about it, let's go ahead and take it to the list and we can do a longer dialogue, but, so so this is for review. So, take it to the list, provide the feedback. We'll look towards another revision.
Can I get clarification? You've already tagged this as candidate for working group adoption.
Yeah.
Is that the same as actually starting a working
No,
group
I'll probably
adoption
start that in the next week or so. Okay, so I don't like to do too many at once. So once wire format finishes, I'll kick another one off. So, okay, how's that? And then we'll take it from there. Okay, thank you. So there's two drafts here. This is Warren and Wes's multiple responses, and then Ray has one on multiple queue types. And they're both dancing around, I think, the same problem in different ways, which is kind of why I know Wes says I'm wrong. So it's okay, I'm wrong.
You're wrong,
Okay.
sorry.
Okay.
So I'm Wes, this is Warren, and our other author is currently on a plane on his way here, so you'll see him later in the week. This is a talk about how to do multiple responses. If you look at the world today in DNS, we end up doing a number of things. We request something, and then a while later, that sort of triggers us to request something else and request something else and request something else, and we end up requesting multiple things one after the other. So as a couple basic examples, you go off to a web page and you go, hey, www.example.com, and then you parse all the stuff. And then you find out that you need to go look up CSS and images and api.example.com. And you end up making all these queries later. For mail, it's similar. You end up looking up an MX, and then you need to follow that up with an A record request for mail 1 and mail2.example.com. And then if you're doing Dane, you need to look up the TLSA record for _25._tcp.mail1.example.com and mail2. And again, it's this chain of stuff. And the only reason that you don't do this up front is that you have no clue what to request in a few minutes, right? You haven't learned what the next requests are going to be, which is why we differ from the other drafts. And we'll get to that more in a second. One more example is serve records. If you go look up, the serve record for IMAP, you may find out that you need to go look up a number of A records after that as well. All of this could be sort of bundled together by the server if the server was smart enough to send you all the records that you were likely going to want based on what you're looking up. And that's exactly what we're doing. So back in 2010, I did this graphic once and I've been too lazy to ever repeat it. But I looked up CNN, and each one of those lines on that graph is a DNS request from the recursive resolver that I was querying through to look at the CNN webpage. And it was that crazy then. It really hasn't gotten better, right? Because you're looking up Facebook widgets and all sorts of other stuff too. It's not just all to CNN. So if we zoom in a little bit, on the left box is doubleclick.net, because that was very popular then. I think it's still popular now, I'm not sure. And on the bottom one is actually CNN web servers, and you can see that there is orange lines coming in and blue lines going out. So every orange line coming in is a DNS request to one of their authoritative web servers, and that's what the three little circles are. And they're looking up www and svcs and a couple other things, ads.cnn.com. And all the blue lines going out are all the answers. And so, can we optimize that and make it better and faster and prettier than before? So how many of you have read the document, just out of curiosity? No, excellent.
Okay.
That either means it's going to be received well or we're about to have a fight, one of the two. So what this proposal is it's really just a bundling proposal so that the server can send you enough data that you might want to make use of it. It's zone administrator configured. We talk about some optimizations. If somebody wanted to get smart and write a packet sniffer and figure out, hey, I can optimize your traffic, that's fine. But the reality is that we actually define records that you can insert to say, I want to bundle these things together when somebody asks for something. We'll see that in an example in a minute. It is not a way to ask for multiple questions, which is what the other drafts are sort of talking about. This is a way for us, because you don't know the questions yet, right? You haven't learned far enough in your HTML parsing or whatever to learn what the other questions are going to be. So this is a way for us to give you more data than you thought you were going to need, because you're going to need it in a minute. We know you're going to come back and ask for it. So it's not competition with the other documents. It's actually a completely different use case. So really quickly, it works by, we did define an extra flag so that you actually have to set the extra flag, which is an EDNS0 option, in order to indicate you support this kind of thing and you're willing to take extra data. We don't want to send it if you're not going to use it. And the authoritative DNS server then it gets instructions on what to send with an extra RR type that would go into the zone file. And it sends an answer, of course. And it also fills the additional section with more information than what is filled today. And it may have to truncate that to fit in the transport in question. So, you know, if it's limited by a packet size, it may have to drop things off. So there's some prioritization that goes on. And clients actually can query for the extra RR record as well, but we don't find a great use for doing that, but we don't exclude it. So the extra RR record, you know, basically specifies when somebody asks for this name and this type. So when somebody says, hey, I want the quad A record for www, here's the extra stuff that you can send back with it. You can send back in, for this example, so we have www, there's an extra record, and when you're asking for the A record for www, priority 10 is an A record for images, priority 10 is an A record for CSS. Looks very much like many of the other priority records that we have in DNS. Then, you know, if there's still room, priority 20 is send back a CNAME for API, which is pointing to api.magic. And since you're likely to come back and ask for, you know, the magic subdomain as well, we can also send you the NS record and the DS record for magic to sort of bootstrap that as well. So, you know, this is just sort of a fairly complex example of the types of things that you can do. And this all goes back in one packet instead of doing, you know, 6 transactions total. Couple of restrictions. You can only do this on the authoritative server. You can't answer for other portions of the tree. It must be DNSSEC signed. In the past, you know, there's been all sorts of concerns with cache poisoning and stuff like that. So we only support it for DNSSEC. You have to send all of the DNSSEC related RR SIGs to go along with it. And any questions? If you have questions, I'll turn it over to the man with the hat.
Perfect. Not questions, but just a remark. I mean, if I'm an attacker, I'm going to query the extra record and then see, well, what damage can I do? And then instruct my botnet to actually query the rest and then pretty much DOS your service. I mean, I don't see most of the stuff you're having here in the recursive resolver. The stuff's cached anyway, and it will be refreshed anyway. So what is the purpose other than kind of DDoSing yourself?
One of the things that we put into the draft, originally we actually had it as a requirement that you used either cookies or TCP, so to get around that particular issue. After lots of discussions, it was sort of determined that some people don't like that, so that should be administratively configured. So we now say in the security considerations, you may want to only support this under cookies or TCP, or only do it when you know you're under attack. You're getting too many requests.
Which limits the numbers of clients that can probably use this.
Possibly, but you know, so does DNSSEC and other stuff. So.
Christian with Microsoft. I'm looking at this optimization. I'm looking at your example of the web page. And then I'm wondering, what is the proper level to do this organization, to do this optimization? Because most browsers already have logic like that. They know that they have cached what is in the CNN web page, and they know that when you consider the CNN web page, yes, of course, you're going to ask for double click, and you're going to ask for the images, and you're going to ask for that. So they typically will send the individual queries for those things because they have cached the structure of the page before. So we have like this 2 level of optimization there, and I wonder which is the best.
So yeah, Chrome does something very similar. However, that only works for sites that you've already been to somewhat recently and you already know what other records are needed.
Yeah, but that's a large fraction.
Yeah, it is a substantial fraction. That's for web stuff. For a bunch of other things like If you get the MX record, you're also going to need the A records, and you're potentially going to need TLSA records. We use web because it was an easy example.
That is
not necessarily
that
the main.
is true, but even in the case of the self-record, for example, you may get, 20 self-records, but you're going to query 2 A records because you're going to do your weighting and says, oh, I really want this one, not that one, and go for it. Okay.
So we're going to close the mic line, but go ahead.
I think that we probably even haven't identified all the possible use cases, but one of the reasons for doing it, can this be used for the web? Yes. Can it be used for server records? Yes. Can it be used for to bootstrap the TLSA records? I mean, there's a number of cases for it. This and Quad A, this happens to do it at a very low level, sort of in the DNS kind of way. You're absolutely right that in many cases, this does not help a resolver which has already cached the information. Of course not, right? This is bootstrapping for the cases where that's not there. Whether to do it, per protocol up above, you could argue that, you could do it in other ways over HTTP with a new header, right? But this actually works for all of the examples at once.
Yeah, I'm a bit worried that basically this optimization is going to conflict with other optimization and might result in extra traffic.
Possibly. I mean, there is already some work to try and embed DNS stuff in the HTTP layer, so that when you do a HTTP request, you get all the DNS stuff as well. It feels like there is a lot of stuff trying to make things faster, and this is another one of those, let's reduce latency, because a lot of people are very concerned about latency.
Yeah, I think it's Jim. Is it Jim back there?
Yeah.
Yep. And then Sarah.
Yeah, Jim Reed speaking for myself. An observation and a question, Warren. The observation is, I think this is us reintroducing the any application attack by the back door, and I'm kind of worried about that. My question though is that this sounds like it might be an interesting idea to explore, but before we do that, could we maybe get some data on whether or not this actually is an optimization or not? It sounds like it might be an optimization, but we could perhaps look at some of the existing DNS traffic patterns and blogs to say this will give a benefit, and if so, what that benefit is, because at the moment, I'm undecided as whether this actually, the cost of doing this, the complexity of this, and the risks of that are worth the benefit of it. And I think it'd be good to do that analysis.
Yeah, it's 100% just an optimization. We'll try and collect some data to show, how much it helps under what set of conditions.
Yeah, I think it'd be good to do that. I mean, what difference does it make to resolver service compared to the existing setup? We don't seem to know that yet.
Sarah Dickinson, Synodon. You probably already thought this through, but I'm just wondering, is there any potential interaction with eDNS client subnet in the fact that...
So, yeah, one of the things, where's the clicky? Do you have the clicky? One of the things that we sort of thought about that was that it has to be the authoritative server that's actually providing the answer. You can't go, get it from somewhere else and then provide it, because you won't know what the best client subnet or geolocation thing is.
Right.
So yeah, we've got that. But if we could just collect all data that the client might need, go from proactively fetch and stuff it in, then all DNS stuff could happen in one lookup. But because of that, we can't.
Okay, thanks.
I'll take the blame for that. It's on the slide. I didn't read it.
Magnusha, is there any problem with DNS 6.4 with this? I'm thinking about it. And
maybe. Well, yeah, that's true. It requires DNSX, so you're already screwed on that side.
Teddy Hogborn, Nordisk Media Utveckling. This all seems nice, but I have an issue with the wire format and the syntax. It seems like it's just, a TST record in disguise.
No. So it is not. It was in the last document. It was. So this, I didn't qualify this bottom section. So after multiple discussions, both on the mailing list and in hallways here, this is sort of the most agreed upon thing at the moment. I think that the format of the record will likely change as the draft moves forward through the working group. It's still subject to debate. So the current belief is this bottom set of multiple records is not text format, it's binary format. And there's multiple records based on the discussion on the list. I don't know if you participated in that discussion or not.
Good, then I don't have to yell at you. Okay. There's another comment. Someone asked if this was an optimization. I mean, the fact that the server doesn't send this stuff has been used as a motivation to not use SRV records in new protocols. So apparently many people believe that it would be an optimization.
Yeah, for low latency stuff, you know, phone calls and zip connections and stuff, you're absolutely right that people hate the DNS because it requires too many trips. Yeah.
David Lawrence, two thoughts. One is just on the ECS question. I think you still have some problems in general, which I think is more a problem with ECS that needs some revisions itself. But one is when you do pump these records in, you can only then the EDNS 0 option really only provides for one subnet to apply to the entire answer. And so you couldn't specify that, in fact, maybe one of your answers is a global answer, which a resolver could maybe ultimately figure out through other means, but you'd be forced to give the most specific answer. So that's a bit of a drawback. I confess I haven't read the document. One of the things that I thought of while looking at this slide that I was a little concerned about is the fact that now you have, I hope that there's guidance in the document for how an authoritative server would ensure that the records it's providing back are in fact records it's authoritative for. The issue being, for example, say when this is originally set up that images is in fact in bailiwick in the zone, the server is authoritative for it, but then somebody comes along later and delegates images away, but there's still a glue record present or an included record for it. The authoritative implementer would have to be kind of aware that they'll have to handle that type of possibility that perhaps at a later date, the data would change in such a way that makes these extra statements now not quite right.
I think that issue still exists with DNSSEC and other stuff related today. I mean, even without DNSSEC, right, you still have the TTL issue of things change. So
right, and I'm not saying that this precludes this. I think it just needs to be called out explicitly as a configuration
it's worth a
issue.
paragraph. You're absolutely right. So, you know, the last question that I had, and I have to show it because it shows Warren in another really cool hat, was whether we should do adoption, but I'll leave that to the chairs as to when the right time for that is.
Yeah, I think we'll kick that off. If we do that, we'll sort of see how the discussion on the mailing list goes and probably
It sounds like you might,
you need another pass on the document, it sounds like, to sort of flesh out a few things.
yeah, it feels like this has been substantive. So if you,
Little tiny things. I think the majority of it, except for that last, the format of the record, I think is probably the only thing that will be a substantial change.
People in general think it's yeah, I guess we can do a quick hum. Yeah, how about we hum if you feel like this is work relevant to be doing.
I'm ready to adopt.
Relevant and ready to be ready.
Yeah.
Well, no, not for adoption, but whether or not this is like really, you know, is this is it a candidate for adoption, right? Do we think it's relevant? Okay, I don't want to do hums for adoption. I'd rather do those on the mailing list, you know. Okay, you can do it a different way.
Can people, so we're going to have two hums. One, hum if people think that it's a good idea and we should carry on working on it. Two, hum if people think it's a really bad idea and we should never speak of it ever again.
Yeah.
There's a third one, and I'm doing because I'm taking the minutes. I think Jim's question is really good too. Is do it after you've gained some data on it. I think that's a valid question. It's not just yes or no.
Although if people think it's a bad idea, we won't bother collecting data.
I understand, but I would like to hear that one as well because I heard a couple of people grunt after Jim said that as well.
So 3 hums. 1, if you think this is a good idea and we should carry on spending time of it. 2, if you think we should collect data and then figure out if we think it's a good idea and we should spend time on it. 3, if you think it's the world's worst idea ever. So hum now if you think this is stuff that we should bother working on some more. Hum now if you think you can't decide until we have more data. Surprising that. Hum if you think it's the worst idea ever.
For the remote, that sounds like a stronger hum for get more data.
Okay.
So we'll look for that. We'll look for that revision. Wonders will never cease.
So hi, me again, still frazzled. Right, so this is a draft that was actually originally submitted to DNSX when we had a DNSX working group about 3 years or so back. This is one of these how do you ask multiple questions at the same time drafts. But the intention of this one is to be as simple as possible.
One of the issues with some of the solutions that have been proposed for multiple questions is that they basically involve actually putting multiple questions in the question section. But I'm also well aware that there are quite a few systems out there which will complain vigorously if you try to do that. There's also problems with the R-code semantics. What happens if you ask two questions and one of them is an X domain, one of them is maybe no error, no data, or even something like produce a surfail or something like that. I think I've also seen a draft which was suggesting that extra queries could be put inside an eDNS option. I think that could work, but I'm also concerned that it would be potentially quite inefficient because, as far as I know, although Mark maybe thinks otherwise, you can't actually compress the R data in an eDNS opt-RR. Certainly, I'm trying to remember the number, 3571 is it? The unknown RR types says you can't compress an R data unless it's an RR that's specified in RFC 1035. The bit that's questionable as to whether that anticipated the presence of transport meta RRs like an opt-RR. Although that said, that document does post-date eDNS. But nonetheless, that's what that one says. So instead of my hopefully simplified design is that I would constrain the problem space to saying that all the questions must actually be for the same owner name. The primary Q type that you're interested in would be the one that's actually in the question section. And there's then an eDNS opt-RR which contains a short list of additional Q types that you're interested in. It's also got the same Q class. In the response, similarly, the opt-RR has got to be included. And if you've got an answer missing for a particular Q type, but the Q type is still present in the response RR, that means that that particular Q type doesn't exist. Alternatively, if you get the response RR and the Q type has been omitted from the response opt-RR, that basically means I actually don't know whether this one exists. And that's to support the use case of a stub talking to a resolver, where potentially those additional Q types are not yet in cache. There's been some discussion as to whether there maybe should be some signaling to say, to allow a stub to say, I really would like to get all of these answers. I am prepared to wait for you to fill your cache with them before you send back an answer. I think, as I've already suggested, if you don't know how to handle this RR, it's exactly as if you asked the question for the original primary Q type, because the opt-RR should be ignored. I've identified there is potentially a problem with the AEA bit, potentially particularly relation to the NS and DS records, because the answer to whether the AA bit's set for some of the queries depends on whether you're talking to the child server or the the parent or child side of the zone cut. So that may need some work, or we may need to decide it doesn't actually matter, it's irrelevant. I had some complaints before that I've got a 3-bit field in there which specifies how many additional Q types are in the opt-RR. In theory, you can determine that implicitly from the length of the R data of the opt-RR. And I've got some sympathy for that position. Yeah, that's certainly feasible. I suppose maybe the counter on that one is that the fact it's a 3-bit field means that it effectively implicitly constrains the additional Q-type list to be a maximum of 7 long, which may be a good thing. I mean, there'd be a danger that if we didn't have that constraint of having the QT count field in the record, that you could ask for 200 different Q types and maybe get quite a few of them back, and that might not be a good thing, particularly for amplification purposes. Actually, speak to a couple of things actually before we go into further questions. There is a bigger meta question about, is this even worth bothering with? There have been a few different proposals over the years for handling multiple questions, but they get varying degrees of, I suppose, mud thrown at them. I personally think this is the simplest one that has been proposed so far. Again, it is just an optimization. But I'd maybe like to suggest that if we decide that none of these are worth doing, that perhaps maybe it's about time we actually wrote down a draft that actually says, we have considered this, and these are the reasons not to do it. So that might be an alternative approach on that one.
That's not a bad idea, actually.
Yeah. Okay. Actually, before I go to questions, sorry, if I may, a very quick plug. For those of you who don't follow some of our other mailing lists, You can now get some Dig for iOS. So if you're on an iPhone or iPad, you look for IC Dig. Just wanted to announce that that's available. We've got a iOS wrapper around that, which I know various people have already tried and liked.
Yep.
And then any questions, please, about the draft?
I'm John Levine. It's not clear in your draft whether this is likely to be more useful from stub to resolver or resolver to authoritative.
Yeah, it's intentionally vague on that respect, because I think it's actually useful for both.
Okay. Yes. My other question is, where do the C names go? If I did 3 queries for 3 types, I would get 3, and it happened to be indirected through a C name, I'd get 3 copies of the C name. Or do I get 3 copies? Do I just get one? I mean,
Well, if you get a C name back, then in theory the server could just send back an answer without the opt_RR, and it actually returns the C name. And at which point, as far as the client's concerned, job done.
but if it's from the stub to the resolver, typically the resolver will follow the C name and give you both the C name and the answer. I mean, I think this sounds to me like, not having thought about it very long, my guess is this is one of those things where any answer is okay so long as we all agree what it is. But I'm just wondering if there's other gotchas like this that could surprise us.
Yeah, it's an interesting question. I'll have to think about that.
1 second, Mark. Mr. Fujiwara is back there.
I'm Kazunori Fujiwara from JPRS. There were many proposals that try to send multiple queries in one request, and all of them are failed. So we need to start requirement and previous summary, I think.
Okay, so can I summarize that? I had some trouble understanding you. I think you're saying that we need to say why they failed and just draw a line under it? Okay, don't worry. Okay.
Mark Andrews, ISC. Going back to the C name, the first query will always, C names are unique and can't exist with other data. There's one exception to that, which is the key record, which can coexist. But what you do is you put the C name in first, and then do the correct thing, which is take the target of the C name and fill in the remaining data for all the query types. If we're really worried about DS versus others, we can rule the pairs of those DS cannot be with other types, things like that. We can do this.
Back in the back. Yep.
So I think, as I said, there are enough other proposals out there that failed and for a reason, and I think it might be worth actually considering writing something that we shouldn't do this. There's only one use case I can think of that makes sense in this regards, and that is really for transitioning networks having a quad A and an A record in the same sort of query. As everything else is just sort of putting into the amplification realm, because you get back large answers and you then have to deal with them.
There's MX plus A as well, because you can ask for the MX and then get back, in the absence of an MX, you can get the A record as the 0 priority. Or in fact, actually, perhaps you
But
do
only
MX
if the A
and
record,
plus quad A.
only if the A record is at the same queue name, which in most of the cases is.
Well, if the MX doesn't exist, then the A and quad A would be at the same queue name. So you could actually, it would be useful optimization for that. I suspect there may be a few other use cases other than just pure A plus quad A.
David Lawrence, I was going to address the same meta question and with the opposite sense of Ralph, in that I had been independently working on something too, because I didn't really care at all for the opportunistic A quad A draft. That was fatally flawed, I think. And I like this generalized mechanism. And even if it is only ever really practical for A plus quad A as a transition mechanism, I still think that's pretty useful. So.
I do recall we exchanged emails back in April, so maybe we should touch base on that again.
Yeah, we're going to close the mic line here, but go ahead. At the back mic, I think.
Hi, Peter Alexis, Power DNS. So I only read the draft, not the mailing list. You're copying the QR bit in the eDNS option.
Yeah.
What are you working around, and is this really still needed on the current internet?
Okay, so I see Mark still standing there, because I know he'll have a view on this one. But that is a defense against systems that simply echo back eDNS options without doing anything with them.
Is there any data on how many there still are on the internet?
Yes.
Copying those semantics.
They certainly exist. That much is evident. And because the semantics of this option require that the server come back with a response, and the presence or absence of those records is effectively equivalent to saying there is no data for this queue type, or I don't have the data yet for this queue type. It is just that extra defense to say, yeah, if you got back exactly the same thing and the direction bit was 0, that means you know you've had an echo come back. Whereas if the bit's been flipped, you know that means you know that the far end has actually acted upon it. The alternative, which could work, but I'd be less in favour of, would be to have one eDNS opt type code for the request, and then an alternative type code for the response.
Yeah, okay, you're right. But should we really defend still against all this old stuff?
I know Mark thinks we shouldn't, but
Mark Andrews, IC again. Tim, do you want to throw up a graph, web page?
Oh, I can't, but I know what you want to do. Yeah.
Yeah, we have measurements for this.
Yeah.
So if you go to ednscomp.ic.org and look and follow the graphs from there, you'll see there's multiple percentages of servers which echo unknown eDNS options.
Yeah, you two should sit down and talk. Mark will show you lots of pretty pictures that show you crazy stuff. So, okay. Yeah. Okay, that's cool. Yeah.
So Shane Kerr, Beijing Internet Institute. So I'm just going to repeat what I've said on the list. I guess it's okay, but I think this can have a potentially huge win, even if just in the A and quad A case. And I think that win is between the stub resolvers and the recursive resolvers. I think you could cut your number of queries almost in half, which I think would be a huge savings in CPU time on the recursive resolver. So I think that alone merits going forward with this. And I prefer the general solution instead of the special case A quad A one.
Maybe this is one of those cases where we collect some data, right? Yeah. Well, we were going to discuss this, whether or not we take a hum and whether or not this is relevant. If there's interest in sort of this is an interesting, or if there's no interest, if we actually write up a document saying we've looked at all these different options for doing multiple replies and stuff, and here's why they all sort of suck, kind of thing.
yeah, I'm in no hurry on this one. It's been second around for like 3 or 4
Okay.
years anyway. But
Okay.
I never resist getting more data, but I would be shocked if it was anything other than most client queries are for addresses, and most of those are dual. So
Yeah. Okay. Oh, no. I think we'll wait because I want to sort of figure this out, sort of thing. Okay. Okay. Thank you, though. We're doing okay. Okay, John. Where is? Yep. One more new topic. Oh yeah, I was trying to figure that out.
Good afternoon. Good afternoon.
You're taller than Ray. You need to pull up the microphone a little bit.
Is that better? I'm here to discuss bulk DNS records. Basically, this is not to be bad-mouthing dollar generate, because I love dollar generate, but it does have a few shortcomings. The first is it can't be transferred intact. If you have a generate, it's expanded. When you do a transfer, the other end gets thousands of records or so forth. Another problem we've run into is a singleton in the middle of a generate breaks the generate. So it has to be broken into 2 generates and so forth. Another topic or another issue that we have is it doesn't scale huge. When you start getting into the IPv6 reverse records namespace, it just doesn't scale. And last is it's not a standard. It's not in every name server implementation. So these are some real world issues that I've seen in the wild. The first one we've already gone over. The transfers are different when you from the master zone to the transferred zone. We've already received requests for /96 reverse. That's just not a good idea with the dollar generate. We need patterns that can be exist without being broken by singletons. We also need lower memory footprints. When you talk about the large scale, it just doesn't. The numbers are just too big to scale, breaking them into individual records. The last thing is zone compatibility with other DNS implementations. So you want to be able to transfer the zone from one server to another server and have that record intact, or those generated records intact. This is the format of the draft. This assumes this is a IPv6 reverse /64. It assumes that the origin is a lot of zeros and the end there. There's two separate record examples here. The top one is an expanded, a little more complicated, but easier for the operator to enter. Has a wildcard as the owner. The record type is bulk. It specifies that it's going to expand to be a pointer. You have a pattern that it's going to recognize as the first part on the first line, and then what it's going to expand to on the second line. The second one, the second example here, very similar. It uses what we propose as a hidden wildcard, so you don't, and you can't query the bulk record for the entire namespace that it's speaking on behalf of. It still exists, but it's in one place. Only the bulk records are going to be expanded, or the PTR records will be expanded for the wildcard namespace. The same PTR record is shown. Another hyphen, which says I match everything. And that's going to be captured into a pattern expansion where you see the dollar and the curly brackets, which is going to expand to fill the rest of the namespace with what was captured, delimited by hyphens as the default delimiter for the PTR record type. So why do we want to go this route? We want a standards-based solution. No more hacks. We've had vendors that can provide this functionality, but it's going to be vendor specific. You end up with vendor lock-in, and you can't recommend it or use it with other customers because they may not have that vendor. We want to eliminate the singleton collisions. One thing that's different about this is it only exists where it would normally result in an NX domain, meaning that these records are superimposable. There are no collisions. We have a simple to use syntax for the administrators and operators. It can act like a dollar generate, but still be transferred with an AXFR transfer. Again, it can only exist where other resource records do not. It can easily manage over 18 quintillion pointer records. I just like using that example because it's easy for people to realize that's a big number. It's just 18 with 18 zeros. And it natively supports DNSSEC. And just a B card.
Yeah. Yeah, I guess it's the end of your slides. John had actually submitted this draft some time ago, and I guess because it's long and the implementation looks fairly complex, it wasn't getting a lot of attention. But it also seemed to us when we talked with you that there's a real issue here that we've heard about before and we'll hear about again. So the interest is primarily in getting people to read the draft and sort of think about the idea and some preliminary comments, general feedback. We have a couple of minutes for comments, and thank you for sort of coming along to encourage people to pay attention.
Hi, my name is Victor Duchovny. I haven't read the draft yet, perhaps lots of others haven't, so I'll ask some silly questions. You say you prioritize AXFR. Is this record also visible to clients making queries or only between servers that are authoritative?
It's only going to, well, it exists, so it can be seen if you know where it is and you ask for it. But if you use the hyphenated wildcard syntax, it's not going to be included in.
Because in DNSSEC, if you want to prove non-existence, you're going to have to synthesize all the NSECs unless you return this as evidence as the wildcard to the client to interpret. Because otherwise it's very difficult to have non-on-the-fly DNSSEC signing.
Right.
Is that you're assuming that zones doing this will always have on-the-fly, or?
There's on-the-fly, and there's also another record type that allows for pattern-based DNSSEC records to be generated.
And delivered to clients as evidence with signatures and
Right.
all of that. Is that in this draft, or?
It is.
Okay.
That's probably going to.
Right. So that means also client implementations will need to start supporting.
Right. If it's on the fly, the clients don't need to change anything. If it's the other way, you're right. I mean, you can't prove existence, non-existence.
So in what order do we introduce these? Because if I'm operating one of these zones, I have to wait for every client to be upgraded.
Right.
That's DNSSEC client
So-
before I can publish one.
Right. The recommendation is use an on-the-fly implementation. Otherwise, it's just not going to be. You can't validate it with the clients that are in the wild today.
Thanks.
David Lawrence, by and large, I'm really in favor of this. I like data simplification, reduces problems from manual entry and so on. The one thing is much along the lines of Victor's statement, and that I really would guard against trying to attach this to the wildcard label. That seems to be a thorny point in many implementations, getting wildcard rules right, and in fact, DNSSEC makes that worse. And in response to the answer that you just gave, also, while certainly trying to do pre-signing of 18 quintillion records would be a problem, you could imagine this still being used for zones in which pre-signing is completely a reasonable thing to do. And so given that intersection, I'd like to see a different method. I'm not even sure, I'd have to think about it a little bit more, but did you think about just attaching it to the apex? And if so, why was that rejected?
Yeah, we're going to have to cut the mic line. Thanks.
Yeah, I don't know that we actually did think about.
Okay, we can
that.
discuss it on the list.
Yeah.
In particular, I think there's a big red flag of trying to put it on the
Yeah,
wildcard
the main
label.
reason for the wildcard was for the implementation. We were trying to do our own implementation, and the mechanism was already there for the name server.
Yeah, John, one of the things that I'll introduce you to an IETF custom. This is the moment where you say, this is good feedback, and anybody else who wants to discuss it, we should get together and have a beer together.
All right.
But go ahead.
Ted Ugerborn, Nordisk Medieutveckling. You designed this as a record type, but that's not how it's actually used. I mean, you would probably, it seems to me like what you would actually want is a dollar bulk directive.
Well,
in principle, but that's. But
right.
I see that the downside of that is, of course, it doesn't work with AXFR.
Right.
But and also that the actual zone files in memory on the servers would get too big. But there's nothing saying that it has to store all the zone files in that way. It could just store a $bulk directive in some specific way in the server. But what it seems to me that you actually need is a new form of zone transfer instead of a new form of record. That seems to be the correct way to solve this problem. This seems backward and wrong. It's a record that's not a record used for records.
Right. You're right. I mean, it is. It's only used for the transfer mechanism.
Yes, and that's why you probably should design a separate transfer mechanism to fix this problem instead of having a new record.
A good point. Talk after.
601, yeah. Yeah. That's an interesting one. Yeah. Okay. Okay.
Ed Lewis, it was funny when you first started talking, I said, guys, we need to replace AXFR for this to work. But that's not necessarily true, and that's not what I came over to say, just as we have. But one thing I was going to, listen to DNSSEC talk about this, the precedent for this is like the DNAME record, where the DNAME record redirects your query and CNAME does that. The result, isn't necessarily signed, but the fact that DNAME exists lets the other side know I followed a formula like this to get there. So in that case, I don't need to have a signature on the result, but I need a signature on the fact there was a rule to get there. So there's hope in that area to look at some of the precedents for this.
Right. Thank you.
All right.
Point.
So it sounds like you have some thinking to do and some beer to buy.
Yeah. That's quite all right. Thank you, John.
Thank you.
Oh, yeah. Oh, just a quick one pager. We just wanted to bring up catalog zones. I sort of flagged it as a candidate for adoption. It's currently extended experimental, but it's actually being deployed in 9/11. And so there's a draft out there that the folks at IEC have put together. I just urge you all to take a look at it. And so it'll probably sort of come up in the thing in the next month or couple months sort of thing. So that's all. So Suzanne, it's all yours.
I'm so glad these microphones are adjustable. So we are inevitably forced into an update on special use names. I'm going to stand up here very briefly, then I'm going to ask draft authors to update us on drafts that have been in progress. But real quickly, just to recap, because we're about to have to move into a new phase here. After RFC 7686, which was very challenging for the working group and for the IETF to do in the context of RFC 6761, Dnsop asked for a problem statement of how would we know we had made things better. We wanted to understand the problems that had arisen and where they were coming from. At this point, we have 2 problem statement drafts, and thanks to all of the authors for their work on this. It's not anybody's idea of a good time. They have converged significantly in the time that the work has been going on. We've got some differences in perspective that have been challenging to reconcile. And frankly, people are tired. And I don't blame anybody for being tired. However, the reasons why we took on this work have not gone away. It's in our charter, it's as the working group. We have now prominently a use case within the IETF. And I actually got up at the microphone at HomeNet earlier and said, thank you for providing us with the forcing function for the use case. It's helping, it should help us focus. At the same time, it would have been nice had it happened slightly differently, which I believe the chairs in the working group agreed with. We also have a working group draft that we parked some time ago because we weren't sure we could convince, we could get working group consensus and then IETF consensus that having alt as a special use domain name would solve enough of the problem to be worth, frankly, the significant effort it's going to take. So what we're trying to do today, we've asked the authors for updates on the drafts and on alt TLD. If we become convinced that alt TLD solves enough of a problem we have articulated to advance it through the next steps in the IETF process, we'll be able to do that. But that's the decision we're putting on the table. We're trying to unpark it. We're not ready to decide that yet. We are going to have to choose a problem statement. And frankly, there's some discussion we're going to have to do with our AD on exactly how to go about that. Once there is a working group problem statement, and I am optimistic that we're close, we got to start looking at what are we going to do about the issues, including does Alt TLD solve some of the problem, enough of the problem, but also including is there follow-on work that comes out of it, and is Dnsop the place to do it? So that's where I think we are with the process. Our primary purpose today is to get everybody swapped back in on where some of these drafts are in light of recent history and see where we can go from here. But I guess which of the draft authors was first?
Yeah. I think Alon. Click the button.
George. George. Jeff. There we go.
Yep.
So I guess it's Jeff who's tall and we'll have to adjust the microphone again. We have face. It's for the remote.
Hi, I'm Jeff. I'm not Alon. It's a random selection. You've just got me today. There are 4 authors on this draft. This kind of started as something completely different, and it's sort of gone from a sort of requested document into something that a number of us still feel strongly about, and it integrates the feedback from the last meeting in Buenos Aires. I have joined this merry bunch of folk because I'm so enthusiastic about the problem. Not. I'm tired too, but it is a complete rewrite. We're trying to simplify it and actually go down to and focus on what the problem is, a problem statement. And there have been a number of revisions since Buenos Aires. Now, it really is trying to focus down on exactly the 6761 process and the associated registry. It's not trying to look at this larger issue of the namespace itself. And necessarily as a problem statement, it doesn't paint a rosy picture. It is a negative thing. These are problems, not solutions. You know, it doesn't try and offer you a way out. It just simply discusses what we believe the problems are, and they are relatively terse. The document now has 2 sections of problems, one on the current process and the associated registry, 6761, and another large second section, problems relating to the evaluation of candidate strings. So this enumeration is lifted pretty much out of the draft. You can all read, right?
Yeah.
Yeah,
read. Okay, read? Good.
Better yet, read the draft.
Cool. The second section was actually just these issues on string evaluation. And again, it kind of points out weaknesses that we see in 6761. And, you know, with a bit of a snide reference to .home, without actually going through some, I think, better process definition, we'll continue to do .home problems. So there does need to be, as far as we can see, a better process there. And also just this general observation that in the larger pool of the bigger namespace, there are now 2 groups of folk doing registries of names, 6761 and the IANA GTLD process, and this is not going to stop. So there does need to be some way of cooperating, coordinating, talking to each other, because hurling names at each other is always going to end in tears. What can I say?
No, domain names.
So that was this document. You're going to take questions right at the end. So you just wanted a short summary.
Yep.
That's a short summary. Next.
Yeah, what we had talked about was we want to go through the current situation, and then we can take whatever. We'll take special. We'll take. Can we do the other problem statement draft next? The idea would be whatever comments we still have time for.
I'll find it.
Yeah, whatever comments and questions we have time for, but the primary idea is we're going to have to continue the discussion, outside the room.
Okay, I'm Ted Lemon, one of the 3 authors of the draft, and I'm the one who originally caused the problem of having a second draft on this topic. So I spoke about this draft at the last meeting in Buenos Aires. Some of you might have heard that. We've since added another author, Warren Kumari. The document was pretty wordy, and so we've made it less wordy and moved the problem statement, which is the actual goal of the document, up to the front. We've added some new problems to the list of problems. We updated the list of relevant documents. This draft includes a pretty comprehensive list of all of the existing documents that talk about this problem, which we think is really important. And we added some motivating text to the history section. And I realize in retrospect, it was pointed out to me that some of the text in the document was a bit snarky, and that was not my intention, so I apologize for that, and that's been fixed. The thing that I think is important about this document is that it tries very carefully not to say anything about anything except problems. And I think that's important because when we have discussions about this, we tend to have discussions that wind up being discussions about solutions. And if we can't agree on what the problem is, then having a discussion about the solutions can't really terminate. And that's what we've seen when we've had discussions about this on the mailing list in the past. So my goal with this was really to come up with a comprehensive list of all of the problems that we need to talk about, and nothing else. And then once we agree on that, then we can go to step 2 and start talking about solutions. And once we have a comprehensive list of solutions, which I think some of them will be mutually contradictory, then we can talk about a list of drawbacks to each solution. And that is to say, we can list the drawbacks of each solution. And then based on that list of drawbacks, we can pick which solutions we want, right? If we don't go through the whole process, we're just going to keep cycling around with these long, 100, 200 message discussions where everybody's like disagreeing about things and really talking past each other. So that's the process that I'd like to see happen here, and that's why I was motivated to write this document, having read the other document, which I think talks too much about problems, solutions. So if you see any problems, if you're aware of any problems having to do with the 6761 special use names registration process that aren't listed in the document, I would appreciate it if you could point those out to me. And then, I think this is a good document. I think this is a good place to start. I think it's mostly complete. I actually don't think that somebody's going to tell me about a new problem, because we've been having discussions about this for a while, and I think I captured all of them. But so I think that we could actually move on to starting to talk about solutions fairly quickly if we adopted this document. But obviously, feel free to disagree. That's all I got.
Thanks. And I think it's Warren.
Yeah.
Warren? We can do it for you.
Warren can be the Dnsop.
Can I respond to?
Sure, yeah.
No, we're going to do sort of comments at the end. Comments at the, yep.
So this document originally started in February 2014. This presentation was actually from IETF 92 in March 2015. I just updated the date. And it starts off with a whole bunch of gumph about the special use names stuff and what the problem is and stuff and other things and more stuff. And then we actually get to the meat of it. What this does is it has nothing to do with 6761. It doesn't update it. It doesn't change it. It doesn't do a bunch of other things people originally thought it did, just reiterating that. What this does do is it requests .alt as a special use domain name. And the purpose of this is so that people who want to be able to do experiments in the namespace, new ways of doing name resolution, have a safe sandbox to do it in. This will be reserved. If you want to do a new name resolution process, here's a place to go and do it. Some people will probably do it. Some set of people won't. There's no way for us to force people to use this. Then again, there's no way for us to force people to use the special use names registry or anything else related. People can just squat. We're not the protocol police, even though my badge says we are. Nothing we can do to stop it. This just at least gives people a safe sandbox to go and play. For some set of people, this could be a permanent home, especially if your name doesn't need to ever be seen by a human. This seems about ideal. Even if it does need to be seen by a human, this potentially is ideal. We do not want it to be that people who are developing new name resolution systems feel that they're second-class citizens. I happen to like the string.alt. If you were part of the use next time, Alt has its own sort of special set of understanding. This is the alternate space. However, some people might not like that name. We're not wedded to the string. Some folk have suggested not -DNS, similar things. That's open to discussion, as is everything. But I think that this does take a lot of pressure off the process. It provides people a place to do things. I think that that's most of it. One thing which we know doesn't really work is putting it in a string which people can't type. This needs to look and act like, a normal DNS label LDH. And Suzanne had a comment. Okay. And I think that's the summary of this. It is definitely different to the other two problem statement documents. It ain't one of them. It has nothing to do with that.
And we had one more draft that folks wanted to sort of point out, and then we'll take whatever time we have left for comments.
David wanted to chat about an actual use of special use names.
All right, thanks.
Yep. It's not .home.
All right. Go again. Hi, everyone. So I'm David Skenazy. I work at Apple, and I've been working in this case with Stuart on a very short draft to slightly modify how we've been using, or how DNS caching servers use IPv4 only.arpa. So very quick summary of what this is about. NAT64 and DNS64. So cellular carriers are deploying IPv6 only networks, so the ones on the left. Some parts of the internet are still IPv4 only, so you need a transition. So if you want to connect to a host name, you query the quad A because you're on a v6 only network. The DNS64 is the transition box for DNS. It queries both A and quad A on the other side, but if only A comes back, it grabs the prefix from the NAT64, sticks the A address in at the end, and sends it back to the client. And then the client just sends a IPv6 SYN to that, which gets routed to the NAT64, which then safely makes it to the web server and back. That's NAT64 and DNS64 in a nutshell. So one of the problems of this when it first came out is that it's great when you have a DNS host name, but if you have an IPv4 address, then you were stuck. So in came RFC 7050, where the idea was, how do you discover this prefix so you can do your synthesis of the IPv6 address locally on the client device? So in this case, it's a very well-named DNS name, which is IPv4 only.arpa, which resolves to IPv4 only. It has two addresses because NAT64 is insanely complicated, but don't ask. But it returns those two for A, and it returns nothing for quad A on a regular network without a DNS64. And if you are, however, honest with a NAT64 network, so in this example, it's using the well-known prefix 64FF9B, then it will synthesize and return those two addresses, which you can use to extract the 64FF9B prefix. The problem is in RFC 7050, as part of the RFC 6761 special use domain name questions, they said, should caching domain name servers treat this specifically? And they said no. And what we've noticed is, so if you have your client device, your phone, that's making a quad A query to the providers, the phone networks, DNS64, it'll then make an A and a quad A query to the .arpa name servers, who will respond with a very well-known address. This is in the RFC, which is always the same one, and then the DNS64 will reply to you. But we've actually seen instances of this failing. We're not actually sure if the query or the response is lost or the name server is acting weird, but in any case, something goes wrong, and then the phone is left with a v4 address it doesn't know what to do with, and the user is watching a spinning wheel. So what we propose is instead to have the caching DNS server take care of this. So by adding it to the special use domain name registry, but more importantly, telling the caching domain name servers to treat this specifically and recognize that there's no point in querying the .arpa resolver since they already know the answer. They should just synthesize and send it back. And that's it.
Yeah. So Suzanne, yeah.
Yeah. actually, because we're kind of short on time, we're interested, and I don't know if the draft authors want to stay out in their comfy seats, or be up here, but we're interested in, we have a few minutes for comments. We'd like to keep it to what has changed in the problem statement drafts or strong preferences between them, preferably from people who have read the latest versions. Preferably. We're not hard over on this.
So, if you're not going to bring people up, in the latest version of Ted's draft, there's a large history section where they talk about the history, but they don't quote the RFCs. I personally have an objection to talking about history where you can quote things and you don't quote it. So my strong preference is if we go with that document, that section has to be cleaned up to actually be the history that we know, not the history that we remember.
Okay.
I'd like to respond to Ted, who earlier said that the draft that we co-authored with others had some reference to solutions. It would be great if those references that you found in the draft could be sent to the mailing list so you could have updated it, because honestly, I don't see any. And to your point about covering the problem space, I looked very carefully at both drafts in the last few days, last version of both drafts. And there's a fair amount of overlap in the problems that are described. There's some things that are missing in one and something that are missing in the other. One of the main distinction is about discussion on how to evaluate a particular string and what should be the IETF process to look at that particular strings for potential issues. We think this is an important problem that needs to be addressed and part of a problem statement.
So that's actually, thanks for mentioning that, Alana. That's actually a classic example of what I would describe as part of the solution, not part of the problem. In other words, you're describing a problem with RFC 67.6. So actually, maybe a better way to frame this is that your problem statement is and actually I think this may be why I had such a problem with it. Your problem statement is really talking about the problems with RFC 6761.
Mm-hmm.
But my problem statement is talking about the problem. Do you see what I mean?
Well, I would like to respond to this, that that's what we, initially when we were a design team, had been chartered to do.
Right, yeah, no, of course. Yeah, no, and I mean, I really hate that. So I read your document on the flight over to Buenos Aires, and yeah, but so the reason why I felt like I had to write a draft was because I really couldn't figure out how to send you diffs, and I admit that is a failing of my own. It's not the fault of your draft, but nevertheless, I feel like what I came up with was something that made more sense to me, and that's why I published it, and that's why, you know, we've been working on it. And it's not a pleasant thing to have an argument like this, but I think that you actually hit upon exactly what the difference is, and that's actually kind of helpful.
So part of what we need to think about is the implications of, since how you define the problem constrains your solutions, is what are the implications of defining the problem in these ways.
I would like to maybe oops.
Yeah, there is a queue.
I'm sorry.
No, go ahead. You're still on the same topic.
Okay. Yeah, we have a few minutes, but we can talk as long as we have
time. There might be a
time.
way out of all of this is either combining both documents or publishing them separately, because this is really the crux of the issue. One is talking about issues with 67, 61, and one is talking about the more general issues about special names. And honestly, maybe some cleanup to do and publish them separately. That might be a way out.
Well, I mean, actually, I would suggest that maybe we could start with your document as a basis for step 2, in the, well, my slides aren't there anymore, but step 2 was documenting, hi, Joel.
I was going to give our AD the last word, but he can have a word whenever he likes because he's the AD.
Yeah, I think,
Things have changed.
sorry, Joel Yeagley. Yes, something changed.
Since I was an AD.
I think there's a temptation to solve both pieces of it at once, and I'm not sure that we should. We might be getting a little bit ahead of ourselves. I think one of the things that I concluded from the effort of putting together the design team was that it was inevitable that someone else in this community would have an alternative take, and that's not something I would put money on who it was going to be that would write the alternative draft, but I would expect them out of necessity to be different. And so if the effort is around convergence versus selection of one or the other, those are both okay. I think what would be bad would be if we adopted 2.
The chairs agree.
Hi, Ralph Drums, and full disclosure, I'm one of the co-authors of the document for which Ted did 98.5% of the work, and I threw in a few words here and there. So thank you, Ted. I actually quite agree with Alon. The documents in their current state have the problem list up front. You can sort of put them up side by side. I did, a side-by-side comparison. I came up with, not surprisingly, perhaps a different result than Alon did. I think that the TLDRW draft covers, is a superset of the problems outlined in the 2 documents. The other issue I think that I have with the ADPKJA document, there we go, is that there are some of the problems they're not necessarily problems with RFC 6761. They may be points that aren't well specified or aren't specified at all in RFC 761. We made the assumption in 6761 that the IETF process would, in the course of its natural review, deal with those details. We found that maybe it doesn't in all cases, the .home being one of those cases. But I would vote in support of adopting the TLDRW document as a starting point. And I encourage other members of the working group to go do that analysis in that way. Look at the 2 lists of problems, see how you feel about them, and see which one seems to cover the larger set, seems to be the closer to the list of problems we need to solve. Thanks.
Ralph, just one interjection about that. One of the things that I found when I was going over the list of problems that came up as comments to the original version of the TLDR document was that a number of problems were discussed that were actually problems with solutions. And I deliberately left those out of the document because I think that they kind of confuse the issue. We should do that separately.
Right, exactly right.
Yeah. Alon, did you have?
No.
Okay, I wasn't sure, but yeah, I see Stuart standing at the mic. Go ahead.
Well, I was about to say I will sit down because I can see we're over time. But thanks, Ted and Ralph, for writing a very constructive document.
This is Jeff, and let me just respond to Ralph's comment about the problems that we need to solve. And the whole issue is the we as part of this. There are problems that the IETF has the ability to solve as the IETF. But in this particular case, when you're looking at a coordination issue with other folk, part of the larger space is not in the IETF's remit to solve unilaterally. And so in looking particularly at 67, 61 and the issues with that, it's more focused on the IETF's area of activity and domain and things that are soluble inside this process. Necessarily, the broader problem is not unilaterally solvable by the IETF in the IETF's process. There are other parties involved, and that process, I'm not trying to figure out how to do that, but I am identifying there is a larger space. And while Ralph says, yes, that's good, we can't really address that ourselves.
We can certainly
unilaterally.
describe the problems, though.
Right, and
Yeah.
what you do with the problem statement is say that there's a particular piece of the problem here, and what you do with solutions is figure out who, and the IETF does have structures and processes that will act on its behalf if told this is a piece of a problem for the IETF, but we have to get that far. Yeah, I was just about to say.
You said what I was going to say, so thank you. This is
So
Ralph.
I think Joel already got the last word. So I think the plan from here, and what I should have put on the slide was we're probably going to be looking at an interim soon, but what we really want people to do is go look at the drafts with it in mind that we're going to adopt a draft and move one forward as a working group item, and let us know what you think. Thanks, everybody.
Oh, fill out the blue sheets if you haven't. All right.
And enjoy the rest of IETF 96. I'm gonna go.
Yes, sir.
Perfect, thank you.
Thank you. Okay.
How did we do? I think that was it.
Okay. Forward progress. Oh, I'm here all week.